Hey y'all, so we're going to do the hyperbola today, and it's kind of like the ellipse as far as how we're going to get our information and what the general or standard form looks like. It doesn't, obviously, because these are hyperbolas. They don't really look like ellipses, but you can kind of think about, instead of it being like an oval, it's like you cut the oval in half and you flipped the sides out. So that's kind of how the pictures look. So you have these as the equations of a hyperbola. And since it's subtraction, it's important that you pay attention to who's first. So a squared always goes under whatever's first. So like with the ellipse, a squared was under like the biggest, was for the biggest axes. Y'all, sorry, my brain is like fried. For this one, it's just always going to be like the one under the front, but I don't call it A and B, so it's really not that crucial anyway, so whatever. But if I want it to open sideways, if I want like to go out to the sides, like this picture, then we want the X to be first. If we want it to open up or down, then the Y is going to be first. We know it is a hyperbola because there is a subtraction of those two things that are squared. All right, so to talk about foci, which I do not need you to do anything with foci. I just need you to have at some point heard. I don't know what this is there for. Weird. Okay, sorry. So for foci, so just like with the ellipse, you have these little focal points, and it's like the exact opposite. So for an ellipse, it was the distance from the focal point to the graph. If you add those distances together, that stays constant. Well, with a hyperbola, if you subtract those distances, it's constant. So if I take this distance and subtract them, I get a number. Well, if I move this point anywhere along this hyperbola, then I'm still going to get the same number if I subtract this distance and this distance. It's going to stay the same no matter where I'm at, and I can either jump over here, and it's still going to have the same difference. All right, so again, foci, they're these nifty little focal points. They help you get the graph, but we're not going to worry so much about them because you can get the graph without the foci, and that's just more than I want to teach in a video lesson. So again, if it comes into play in your future, please call me, email me. I'll be happy to talk you through it. All right, so for our hyperbola, we're going to get our information similar to an ellipse. We're going to start out by plotting points the same way we would. It's just instead of drawing an oval, we're going to make a box and draw in some asymptotes and get our picture. So let's just jump in and try one, because otherwise things don't make a whole lot of sense if you can't see what I'm doing. All right, so for this one, we are going to have a center at 0, 0. We are going to go left and right 3, and we're going to go up and down 5. So start at 0, 0, go left 3, go right 3. I just said that backward of what I did it. I understand that. Up 5, down 5. All right, so if it was an ellipse, if this was a plus sign, we would just draw an oval and we'd be done. But it's a hyperbola. We have a minus sign. Well, we did until I made it a plus sign. Okay. So we are going to, this is not part of the graph. It's just helpful to get the graph. We're going to draw this little imaginary box. All right, and then we're going to draw the diagonals from the center to the corners of the box. And we're going to do the best we can to make them as accurate as possible, but nobody's looking for perfection. All right, so then the actual graph is either I draw a shape here and here, or I draw it here and here. So since X is first, I'm going to have a horizontal hyperbola, which means I'm going to take these 2 points, and those are the vertices of my hyperbola. And we're going to go out and hug our asymptote from both of those in both directions, and that one wasn't very close to my asymptotes. And then you're done. All right, let's try another one. All right, so just like an ellipse, it has to be equal to 1. So the first thing we're going to do is divide by 100. Y'all, my handwriting is horrible today. Okay, so this is over 25. This is over 4. This is 1. So we have a center at 0, 0. We're going to go left and right 5. We're going to go up and down 2. So again, the square roots of these numbers gives us these guys. All right, so center at 0, 0. Left 5. That was to the right. I don't know why I say one thing and do the other, y'all. Sorry. And then up 2, down 2. All right, so again, use those to help you draw a big rectangle. All right, then we're going to do the best we can to get the diagonals drawn through that represent the asymptotes. All right, so when it comes time to draw the actual hyperbola in, go back to your equation and look. X is first, X is positive, which means we're going to open in the x-axis direction, so left and right. So this is a vertice, hug that asymptote, hug that asymptote. Here's a vertice, hug that asymptote, hug that asymptote. Okay, so just like with everything else, they're not always going to give it to you in the right form. So here they're pretty close. You just need to divide by 9 to make it equal to 1. So we're going to be working with x plus 3 squared over 9 minus y minus 4 squared over 1 is equal to 1. I got 1 because these guys divide off. All right, so we have a center at opposite, opposite. So negative 3, 4. We're going to go out 3 left and right. And we're going to go up. Oh, I had my thumb on the button of my pen, y'all. Sorry. We're going to go up and down 1. All right, so negative 3, 4 is here. We go to the right 3. I said it right that time. So the left 3, up 1, down 1. And we draw a box. I don't know what possessed me to use this example, y'all. Crazy little skinny box. All right, so then we draw in our diagonals that are the asymptotes. Y'all remember what asymptotes are, right? Those little lines that you get really, really close to but don't cross. Except for in some rational functions you can. All right, so again, x is first. I'm hoping there's a one where y is first. I assume there is. I've used this for so long. It makes sense that there is. All right, let's see. So this is a vertice. So we're going to hug the asymptotes and go to the left and to the right because x is first. Okay, so like with everything else, they don't always give it to you in the right form, right? So you've got to do some cleanup. And so this is going to work a lot like the ellipse. You've got to factor things out, complete the square. So you just have to remember that there's like a negative there. So we're going to say take out a 9 from my y's. And we're going to do y's first because y is positive. I do have one where y is first. So we're going to have y squared. And then this is minus 2y plus a blank. I probably should have done this way lower because I'm going to run out of room. Let me, sorry, that made you dizzy. Let me move this down. All right, so 9, and then we have y squared minus 2, because 18 divided by 9 is 2, plus blank. All right, so minus 4x squared. So we're pulling out a negative 4. So if I do positive 24, if I pull out a negative 4, that's negative 6, and then plus blank. 63 has to add to the other side, so he becomes positive, and then we get these counteracting plus blanks on the other side. All right, so half of -2 is -1, so that goes in the factored form. 1 squared is 1. Remember to multiply by the number on the outside to put it over here. All right, then you have minus, bring that 9 down, 4, and then we're going to factor this. Half of -6 is -3. Square 3, you get 9. 9 times 4 is 36. Times -4 is -36, excuse me. All right, so now we have 63 plus 9 minus 36 is 36. All right, so then we divide by 36. All right, I'm going to write it up here. So you have y minus 1 squared over 4, because 936 reduces to 1/4, minus x minus 3 squared over 9, because 4/36 reduces to 1/9, is equal to 1. All right, so that gives us a center at 3, 1. All right, so make sure you caught that. It's always what's with the x and then what's with the y. In this case, they're in the reverse order. So you have to remember to take the x and then take the y. The one on your test does that to you, so make sure you pay attention. All right, so then we need to know how far do we go left and right, how far do we go up and down. So again, remember that it matters what variable they're underneath. So underneath the x is a 9, so that means left, right, we're moving 3. Underneath the y is a 4, so up, down, we're moving 2. All right, so go to 3, 1. And then we're going to go out 3 and up and down 2. All right, so then we use those to make a box. All right, so then we draw in the, y'all, I didn't count correctly down there, did I? This should be up here. Okay, so now I can do my little diagonals. Put in your diagonals, which are your asymptotes. All right, and then to get your final picture, y is first. So that means we're going to open up and down like the y-axis points. So we're going to take this as a vertice and swing out and hug our asymptotes on both sides. And the same thing going down. All right, so domain and range. It's not asked on your test for anything other than a circle, and I don't think it's asked in your assignment for anything other than a circle. But just to say that we have discussed it because it's important, domain and range, for these, you're going to have to say go from here to here, stop, pick up here, and go on. So for domain, we're going to use all real numbers. So you're going to say negative infinity to infinity. But for range, that's where there's like a gap. So we start all the way down and we come up to -1. Then we hop, there's a gap, so we put the union symbol. And then we pick back up at 3 and we go to infinity. All right, so again, I'm not asking you to do that. I was just wanting you to have seen it. I'm also not asking you to talk about foci. So if there's any mention of foci, you don't have to do it. If there's any mention of labeling your vertices, I don't need you to do that either. I need you to do the things that I have shown you in the video on your homework problems, okay? So if it's asking you to graph, I need to know the center, the left-right move, the up-down move, and a picture. All right, if it's asking you to write an equation, the only ones I'm going to give you are the ones where they show you a picture. Okay, and I have 2 examples of that, and then we're done. I skipped the problems where they told you foci, or they told you vertices, or they told you the equations of the asymptotes. We're not getting that in depth in things. But again, I'm here in the future. If you ever feel like you're expected to know something that you don't, please contact me and I will be happy to help. Okay, so if I want to write the equation of the hyperbola, first off, I see that it points left and right. So I know that I'm going to have an x first minus the y. And I know that it has to equal 1 because hyperbolas and ellipses equal 1. The difference in the equation for a hyperbola and an ellipse is hyperbolas have a minus sign. Okay. Your attendance question, let's back up. How do I look at general form and know that I have a hyperbola? The key is that you have an x squared and a y squared subtracted. Okay, so we said for circles, x squared, y squared, matching coefficients, added. For ellipses, x squared, y squared, different coefficients being added. Hyperbola is x squared, y squared, subtracted. Coefficients don't matter. All right, and then we'll talk about parabolas on Friday. Okay, so, attendance question. I said that was going to be it, and then I never said. Tell me how to recognize a hyperbola. I just said it twice. Rewind and listen again if you didn't catch it. Okay, so back to this one. We want the x first because it opens outward to the left and to the right. To get the numbers inside the parentheses, we've got to figure out where this little center of this magic box is. So what's halfway between these vertices? So this point right here is at 2, -5. So that means with the x goes a 2, and with the y goes a 5. Remember that the signs changed because the original formula says minus. So this was minus a positive 2. This was minus a -5. All right, to get the numbers underneath, it's how far did we go out from that center. So from here to here is 1, 2, 3 units. So 3 squared is 9. From here to here is also 3 units. So 3 squared is 9. Okay. Try one more. This one, I couldn't find a picture that I really liked because I wanted to give you one more example since I'm not there to answer your questions in person. But please email me, like message me, whatever, if you have questions. Please, please. So first of all, it points up and down. So we know that y comes first. The hyperbola, so it equals 1 for standard form. All right, so now this one isn't as straightforward because there's no grids and the scaling is weird, but you can figure out what you need to know. You can figure out the center point because you know that it's halfway between 3 and 13. Okay, y'all with me? So halfway between 3 and 13, so that's like what, 10 spaces apart, so half of that's 5, so 8. So if you don't believe me, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12, 13. So 8 is halfway. So we know that this center is at 5, 8. So that means with the x, we put minus a positive 5, and with the y, we put minus a positive 8. All right, so now we've got to figure out how far did we move. All right, well, the up-down is pretty easy because we have this to count. So we went from 3 to 8. So we went up and down 5. So 5 squared is 25. All right, so the left-right is absolutely not very easy on here. But it looks to me like this is a little more than halfway from 5 to 8. So I'm going to say that we're going to call this 8. And we're going to call this 2. The ones in your book are labeled just like this last one that we did. So don't worry so much about the fact that I just kind of made these up. Okay. So how far is it from here to here? Well, if this is at 5 and this is at 8, that covers a distance of 3. So 3 squared is 9. All right, so again, you're going to be able to count because there's grids on the ones on your test. Actually, you don't have to do this on your test, but on your homework. I didn't put write the equation of a hyperbola on your test. Okay. I think that's it, y'all. So let me know if you have questions. Do your homework. Keep up with things because this is definitely new. Parabolas you've done before, but we're going to not just graph this kind of parabola. We're going to graph this kind of parabola. So it's important that you make sure you watch that video and you're ready to go on Monday with a review. Okay? All right. See you later. Oh, I hit the hide button, not the stop button. Sorry.